So here's the problem that we were asked to work on in calculus yesterday. We are given a derivative function, f prime of x equals negative x to the fourth plus x cubed plus x squared minus x plus 1. And the problem was at what x value is f of x the largest?
Okay, so isn't this pretty easy? Can't we just see the answer on the graph? The graph is highest right here. So it will be the largest right around x equals negative 1.
But this is the graph of f prime, not f. Does that matter?
Oh, right. And the derivative tells us about increasing and decreasing. So if we just see where the graph is increasing, we'll be able to find where f of x is the largest. So this is increasing on these two intervals. So f of x is increasing from negative 2 to negative 1, and again from 0 to 1. So this would be where f of x is the largest.
But I don't think that just because f prime is increasing, that doesn't mean that f is also increasing. I think we need to figure out what the derivative tells us about f, where it's increasing and decreasing. Do you remember the table that we made in calculus?
Oh, right. Let's just erase all of this. I remember we figured this out in class. So if you have f prime and f of x, when f prime is positive, f of x is going to be increasing. And then when it's negative, f of x will be decreasing. Isn't f prime positive here? And then here?
I think that you're thinking where the slope of the graph is positive. We just need to look at where the x value, well, for what x values, where the y value is positive.
Okay, so that's all along here.
Yeah, that looks right. So that means that f of x is increasing on that entire interval.
And then f of x stops increasing when x is 1.5.
Yeah, and I think when f of x stops increasing, it should be at its maximum value. So f of x would be largest at x equals 1.5.